Welcome to InnoBuzz Java Video Tutorial Part 13. In this chapter, we are going to talk about the basics of networking. We are going to learn about network programming. We will see the possibility of communication between computers via sockets. We will know what the sockets are, how can we use them. We will see the structure of a network program. Let us see the overview of the chapter. First, we will talk about the layers and protocols. And then, in general, the understanding of socket programming. We will implement one-way communication and also implement two-way communication. Firstly, let's see the basics of networking. The network is a collection of computers and other devices. The network consists of lots of layers: physical layer, data link layer, transport layer, internet layer, application layer. An abstraction layer is a way of hiding the implementation details of a particular set of functionality. The members of a network change information using package. When a computer sends information, it will go through the layers in package. The layers transform the data to be transportable via cables. And when a computer receives this package, its layers will transform back this package to information. So we have talked about the layers. Let's see now the protocols. The network defines lots of protocols as well. The protocol is a system of digital message formats and rules for exchanging those messages. The protocols determine for each layer how the data should be formatted, addressed, transmitted to other layers and to another computers. The computers implement these protocols. We won't show all these layers and protocols, just that what is important to us. These will be the TCP and UDP protocols. These form the basics of the Internet. The Transmission Control Protocol, TCP, is one of the two original components of the Internet, complementing the Internet Protocol, the IP, and the entire suite in commonly referred to as TCP/IP. The UDP is the User Datagram Protocol. Understanding socket programming. What is a socket? The network socket is an endpoint of the inter-process communication flow across the computer network. These protocols are managed by the operational system through a programming interface, in our case it will be the Java, that represents the local endpoint for communication, the Internet socket. We will use Socket API to control these sockets. All sockets have an address that consists of IP address and a port number that clearly define the computer and the application where the data package should be delivered. The Internet socket is characterized by the unique combinations of the following: the local socket address, the remote socket address, only for TCP sockets, and the protocol, TCP or UDP. The socket that uses TCP protocol named stream or connection-oriented socket, while the other type of sockets named datagram or connectionless socket. Speak about the differences between the TCP and the UDP. The TCP builds a connection between the local socket and the remote socket. TCP provides reliable order delivery of a stream of octets from a program on one computer to another program on another computer. The octet consists of 8 bytes. The TCP has 3 phases. The connection has to be established before entering the data transfer phase. After the data transmission, the connection termination closes the virtual circuit. So the TCP may guarantee the following: the ordered data transfer, the retransmission of lost packets, error-free data transfer, because use sequence number to identify each byte of data. It also guarantees flow control, limits the rate of the sender transfers. The receiver continually hints the sender how much data can be received, and it also guarantees congestion control. Other programs which do not require such reliable data stream service use the UDP. UDP is a simple transmission model which provides an unreliable but fast service. The datagrams that UDP sends may arrive out of order, appear duplicated, or go missing without notice. The most advantage of the UDP is the speed. Let's continue on understanding socket programming. The structure of the network programs that we are going to talk about now. In the communication between computers, there is always a server and one or more clients. The server has a socket that is usually listening to a specific port, waiting for clients to make the connection request. The client knows the name of the host, which is maybe identified by IP number, and knows the port where the server is listening. In a typical TCP connection, the client tries to rendezvous with the server and also identifies itself. If everything goes well, the server accepts the request and gets a new socket to the same local port and sets the remote address to the client. The connection is established between the server and the client with the sockets. If you want to understand the server-side programming, we have to see the differences between the TCP and the UDP ways again. If you want to use the TCP, we have to create a socket in the server side. We have to set the port that we want to listen to. With a method, the program will wait until a client wants to rendezvous with the server. This method returns a socket type object that will describe the client socket. We have to define 2 streams, one for input and another to the output. It is 2 instances of input-output streams that we have learned in the last chapter. If we want multiple clients, we can create new thread when the server accepts a client's request. The other way is to use the UDP. If we want to use UDP, we need just a datagram socket on the server side, and it receives the packets with the information. Let's talk about the client side now. In the client side programs, we need to create the socket. It will be the endpoint of the communication on the client side. If you want to use TCP, we have to create a socket in this side too. We have to open streams in this code too. One reader and one writer. So in the TCP we need a socket and streams for establishing the connection. If we use the UDP, we need a socket for sending data, but we don't need streams because we send only datagrams. Implementing UDP communication. Let's see the one-way communication with using UDP protocol. The server calls the constructor of the datagram socket and creates a new instance of datagram socket in the selected port. Create a byte array for the datagrams and a new instance of the datagram packet. Its constructors need that byte array and the length of it. So this is the byte array and we give the length of it. We call the receive then of the datagram socket instance and set the created datagram packet to its argument. If the client sends message to this server on this port, this datagram packet will contain the message. We have to surround it with a try-catch block because the socket constructor may cause socket exception and the receive method may cause input-output exception. If we want to reply to this message, it contains the IP address and the port number of the sender machine. After we receive the datagram, we should close the socket by the close method of the datagram socket class. In the client side, it is very similar to the server. We should call the datagram socket constructor without any argument if we don't want to receive messages. And when creating the message with datagram packet constructor, it needs the host's IP and port number. The message will be a byte array. The send method of the datagram socket will send our message in the argument that is a datagram packet. Well, the whole thing in UDP communication is this simple. We are going to do some practice now on the UDP communication, UDP protocol. We are going to create a server and a client here. We are going to create packages and send and receive with using the UDP protocol. I have already set up a UDP server Java here in our test project. It's empty. I've already imported the java.net and the java.input-output packages that we are going to use. I will put my code this time into the main method simply and just start it. As we have mentioned, we have to use the datagram socket for this kind of communication. I initialize it to null. So we start with null, and as I have mentioned, these methods and these objects can throw many exceptions. So I have to put it in a try-catch block, put everything, even the instantiating of the socket, and I use a socket, which is going to be the datagram socket. Okay, but this is going to work with a port now. So we have to watch a port. Our port is going to be this time the 1257 port. I can write other ports here as well, but let's use this one. So we are going to use the datagram socket on this port. Well, we have to catch some exceptions here because we get these errors. The socket exception. Socket exception. We have to handle these. And I'm also going to catch the EO exception because we are going to use some input-output things as well, and that's why I need the EO as well. So that's it. So now I catch the exceptions. Yeah. Of course, I have to write a new. Okay, so we have the new datagram socket here, and yes, and what I have to use is a byte buffer here to be able to receive the data. So I use a byte array, a buffer, and this is going to be a new byte array with simple, I specify a size like 2000 or something. We are going to get the data into it. Okay, now I want to watch what's happening, so I use a while cycle, an infinite loop, and of course if we are writing programs we can use better conditions than this. This is just for trying out, and we can change the condition from our program or start it and stop and things like that. What we need is a datagram packet, as we have mentioned, and this is going to be direct request. We need new datagram packet with using this buffer, and also we have to give the length like this. So the datagram packet is going to get the request from the client, and we have to use the followings. We have to use the socket and receive a datagram packet, which is the request. And that means already put it in there. So we are going to receive the request like this, or put the data that is in the request. And what I'm going to do is create a new byte array here, because I want to get only the part of the buffer that I need. In fact, no, I don't need this at all. Okay. The best is just simply to write a for cycle. This is the easiest thing. So we start from 0 with an integer, and we go until I is smaller than the request dot length, get length. So this way we can see what we got. So we cannot go through all the buffer. We are going to only to see the parts that we in fact need. And what I do here is just print out what we have got here. I see the buffer, and the I. So the element at the buffer I is simply buffer I. That's it. So this way I just write out what we received. And that's it. And this is all I have to do when I want to receive something. But of course, to be able to show the communication, I'm going to also reply something. So I am going to use a datagram packet, which is going to be called reply. And this is going to be a new datagram packet a new datagram packet, and with the request I forgot this queue. Requested get data. So we have got a constructor that needs here 4 arguments. The first is the data. The second is going to be the length. So the get length. And I'm going to write it in a new line. We are just simply sending the whole thing back, so we can see if it's coming back the same way. Get address to the same address, and the same port. So this is going to be the datagram packet of the reply. And what we have to use is the socket dot send. So this and the datagram packet sends a datagram packet from this socket. Yes, the length, the IP address, and everything as we've told. So I use this, and the reply is the argument. And with this, we have already also answered to the client. Save it. So we use this port. We create a datagram socket on this port. We are going to use this socket also to receive requests and to send replies. The request and the reply are datagram packets, which are in the request we use a big buffer, which will get the bytes. In the reply we use the same things that we have got. So we just send the data that we received. What I still want to do is write a finally part as well, because I want to close the socket. So if is important, as we have mentioned in the previous chapters, to close everything, every input-output resources and other resources that we have used. So if it is not null, if we could instantiate it and if you could use it, then just close it, and that's it. And now our program is also safe, and it saves the memory as well. Okay, this is the server part. I'm going to create a new class, which is the UDP client, UDP client Java, and I'm going to use the same imports. And what we will have here, I'm also going to put my code in a main method, just simply. Okay. And it is going to be a little bit similar, so I'm going to copy it row by row what is the same. So I use this like this. So I'm creating a datagram socket just like in the other with null. I'm also going to use the try-catch block, just the same. And the final is the same as well, because we will close everything just the same. Yes. Okay. The brackets are all right. And okay, what we will have here is a socket. It's going to be a new datagram socket just like this, but we are not using the port here. Just an empty. And in fact, we will need the INET address that we didn't really have here. So the INET address will give us the host that we are using. So the INET address host is going to be, oh, I'm going to use an INET address object here, and I use the classes getByName method. So if you look at it here, you can see that this gives us an INET address object. This is the getByName method inside this class. And if we give a string to it, this is going to be the name of the host. Then we get the IP address. So it can be a machine name or a textual representation of IP address. This is going to be used by us. It throws unknown host exception, but we catch it because it is the subclass of EO exception. Okay, so the getByName, and we are going to use the local host. The local host here. Okay. So, what else do we need? We will need also a port, just like previously. Of course, I give the same port to be able to communicate. And I'm going to create the message, which is going to be a byte array. The message is a byte array, and I'm just going to get some numbers here. Yes. This is the message that we are going to send, some bytes. Now we have everything together to be able to create the datagram packet. The datagram packet is, for the datagram packet, we are going to use a different constructor. This is going to be our request. And we are going to use another constructor because we are using more arguments here. I use the message. I use the message dot length. So the length of the message is given here. So this is the byte array, this is the length. And we are going to give the host and the port here. And that way the request is already created, and we just need to call a socket.send. And the datagram packet is the argument, which is now the request. And we have already sent it. That's it. What we need to write here is also the getting part. So if you want to get something, well, I use the same thing as here. I will use a buffer for this. So I will use a buffer, and a datagram packet, which is going to the reply, which looks like this. Reply. And we give the buffer and the buffer length. And what we need here is the same thing, is socket.receive. Receive into the datagram packet, the reply, of course. And I'm going to use the same thing here to write it out. Oh, sorry. Okay, I just copy it. So I have the reply. Actually, this is the reply. Dot get length, and yeah, that's it. Okay, we are going to go through the buffer and use the reply length. Okay, that's it, and we catch the exceptions and everything. I think we are ready now to test it. Okay. I start first the server. I run it. The server runs now, as you can see here as well, it runs. And I run the client now. Yes. We have received what we have sent. Here I can show that we have got the message that we have sent. This is the run first. So this is the server Java. This is the output of the server Java. This is the output of the client. And you can see that we got back our message just as we have sent it in the client. The server is still running. So for example, if I change something, if I add one more thing here, like 77 or something, and I save it and I run the client again, then we get it also back. And here we can see that we have more. So we have all the things again. So we received again. So it's still running, it's still watching. The server is still watching, checking what it receives, and we can send and get back things here. Yeah. I do it again. So that's it. Now we got less, but of course, here we got again everything. I just stop it. But this is the way to create the UDP client and server stuff. This is a UDP communication, the most basic and most easy way. Implementing TCP communication. The typical two-way communication with TCP is the following. There is the server side. We create a new server socket instance that will listen on the selected port. Create a writer stream and a reader stream for the communication as well. Call the accept method of the server socket class. The program will stop and wait for a client request. When a client arrives, this method returns the client socket as an instance of the socket class. The connection will be established automatically. This class has a getInputStream and a getOutputStream method. We can give these for our reader and writer streams. The TCP is also communicating with bytes, but we can call a filter stream and we can use character streams. After the communication, we should close all sockets. The client side is a little bit similar as well. We create a socket instance first. We have several constructors for it. If we have a named host, we can set this name as a string, or we can set the IP address of the host by an inet address type argument. We can set the port number and the proxy if we want to use proxy. The streams on the client side should be created by this socket getInputStream and the getOutputStream method. The communication works via streams that we have learned in the previous chapter, the reader and writer streams. Let's do some practice on the TCP network communication ways. We are going to create a TCP server and a TCP client Java here. In fact, this is going to be simpler than the UDP was. I use the same imports. This is the TCP server class, and I will put my code into the main, just like previously. What do we need here to create this server? I create a server socket, as we have mentioned in the slides. Well, this is a server. Let's just call it server S because it's too long. Server S. This is going to be a new server socket. And we are registering it on this port that we've used previously as well. So, of course, it shows us that we have to handle the exceptions. So I put it in a try catch block. And then EO exception. Okay. I have to catch the exceptions also. So we have got a server socket which is going to communicate on this port. What we need to do with this is to create a socket from this the following way. This is going to be called socket, and server S dot accept that we are going to call. This is going to wait and accept the connection, listens for the connection to be made and accepts it. This blocks until the connection is made. So this is what we need here, and the socket is created. From now on, the network communication can work. What do we need? We still need a communication stream. for this socket, and this is going to be an output stream. An output stream out. Well, this is going to come from the socket as well. The socket get output stream. This is going to give us the output stream for this socket, so they are going to be connected this way. Everything that will go out through this socket, and in fact what we need is to be able to send data is a data output stream. Data output stream. No, I thought I copied that word. Data output stream, which is going to we can call it data out, and data output stream. I use the out as an argument. So we need to create a new data output stream with the output stream as an argument. Now, with this, we can already send, for example, a message. In the following way, we have to use the write methods. We have got many write methods here. We can write bytes and double float and UTF strings here. Write cars. I'm going to use this time. Write cars, and I just simply say hello. This is the message that we have sent, and that's it. In fact, we need to close these things what we opened. The data output stream, and also the output stream. And of course the socket. So we just close them, and that's it. So this is a very simple thing that we use here. I save it. The next thing is going to be the TCP client. TCP client. Well, I use the same imports. Okay. And of course I use also the void main here, just like the other. No. Okay. That's it. What do we need here inside this? We will use a socket on localhost. We directly create a socket and instantiate the socket class. The two arguments that we are going to call here. Well, first is the localhost that we used in the UDP as well, and in the same port number. And of course, I put it in a try catch block. I copy it from here. Okay. Okay. I created my socket, and we need to use the opposite of the thing. So it is going to be an input stream. What we use here, our stream, to be able to handle the input. Which is going to the socket from the get input stream. And also we need a data input stream, of course. A data input stream, which is going to we call data S. Okay, and this is going to be, of course, a new data input stream. So we instantiate it, but as an argument, we are going to use the input stream. So this way we are already we can handle the input and the data that is coming in. What do we need here to be able to get, for example, our string in this simple code is to get this message. Well, maybe I just simply data s dot read. I can use the read UTF and the read short, read long, and all these things here. Well, the simplest is to use the read UTF, I think, because it gives us a string. Okay, and that's it. And just I simply have to write it out. The message, and that's it. What I still need to do is to close these. So close them. Of course, I close them backwards because they're using each other. So best to do it this way. Okay, I've closed everything. Yes. Let's see if it works the way we wanted it. I start the server first. It is running. I start the client now. We have got an exception. Data input stream Java. And a file exception. Well, this may be because we have used different methods. I use the read UTF here, and I write the right course here. I use the right course, so I try the right UTF. Okay. Yes. Run the file and run the other one as well. We have got the hello here. So we have received a message. Now, this is not a very complicated communication in this practice. So, but this is the basic things that we have learned. This creating sockets and using the input and output streams to the datas, and we can read and write these data input and output streams through sockets. So the basics are here. You can see how the TCP communication works. This is a simple way.